So the last section in this chapter will be R 9.5, and it's on page 78. So we're talking about scientific notation here, and you've done with scientific notation already, so this should just be a review. So remember, scientific notation can only have one number in front of the decimal. That number shouldn't be a 0. The K, the exponent, tells us the number of places the decimal is moved. If K is positive, the number started off big. If K is negative, the number started off small. So let's look at some examples. So here we want one number in front of the decimal. So we look, the first number we see is 3, so we want the decimal to be right after that 3. So we want to write 3.6, and we don't write all the zeros after it. So we'd have times 10. And then we have to ask ourselves, well, how many places did we have to move the decimal to get it there? Right now the decimal's right here, so this would be 3 places, and then 3 more places gives me 6 places. So this would be 6. Now 3 million is a big number to start off with, so that 6 is positive. In part B, we see the first number that's not 0 is a 4, so we want the decimal to be after that. So we'd write 4 times 10, and we have to ask ourselves, how many places did we move the decimal to get it to be at the end? Well, this is 1, 2, 3, so it'd be a 3, and this is 4 thousandths. Okay, that number is small, so that means our exponent needs to be negative. So we'd have 4 times 10 to the negative 3. So C, the first number we see that's not 0 is 1. We want the decimal to be right after it. So we'd have 1.5 times 10. To get our decimal place there, we'd have to go 3 and then 2 more. That's 5 places. 150,000 is a big number, so 5 would be positive. In part D, the first number we see that's not 0 is the 2, so we want the decimal to be right after it. We'd write 2.05 times 10. Then we have to count to see how far we'd have to move it to get it there. So 1, 2, 3, 4, 5, 6 spots. So this would be a 6. This is a very small number, so we need to have a negative in front of that 6. We'll skip E and F and go on to example 2. So here we have 3.2. The 4 on the 10 tells us to move the decimal place 4 places. The 4 is positive, so we want to end up with a big number, which means we need to move our decimal place to the right. So here would be 1 place, 2, 3, 4 places. Makes our decimal here. The empty spots we fill in with zeros. We go back and put a comma in every 3 spots from the right. So we have 32,000. Here we'd have 2.7. We want to move our decimal place 3 places. It's a negative, which means we want a small number, which means we need to move our decimal place to the left. So 1, 2, 3. Decimal would end up here. Empty spots filled with zeros. So we have 0.0027. And we usually put a 0 in front just to help our eye see that decimal. So here we have 8.2, positive 3, which means we want a big number, so we're going to move our decimal place 3 places to the right. Empty spots get filled in with zeros, so we have 8200. Go back and put our comma in 3 places from the right. And we have 8,200. Here we have 1.25. Tells us to move our decimal place 6 places. Because it's negative, we want a small number, so we'll move our decimal place to the left. 1, 2, 3, 4, 5, 6. Decimal place goes there. We have to fill in these empty spots with zeros. So we'd have 1, 2, 3, 4, 5 zeros, and then 1, 2, 5. And usually we put a 0 in front of the decimal just to help us see it. So in our calculator we can do scientific notation, but we have to be pretty careful about how we enter things in order to make sure we always get the right answers. You should have an EE or an EXP button on your calculator. So the way this button works is you type the number we have at the beginning, and then instead of the times 10 you would hit that EE or the EXP button, and then you just type the exponent. So let's do a couple examples in our calculator. Before we do these examples in our calculator, we're going to write these in scientific notation. So we want to write this as 2.6 times 10, and this goes 1, 2, 3, 4 places, so we'd have times 10 to the 4th. And then times, and let's maybe put that in parentheses so we can keep it straight. So here we want the decimal to be after the 3, so we'd have 3.5 times 10. And this would be 3 spaces and then 6 spaces, so we'd have times 6 to the 6th. So in your calculator, you would type parenthesis 2.6 EE or EXP, and then just the exponent 4, parenthesis, times 3.5 EE or EXP, 6, parenthesis, and then hit enter. When we do that, depending on your calculator, some calculators give you a nice answer, like 9.1 times 10 to the 10th. Some calculators will show you 9.1 EE 10. And that means you just have to recognize that that EE means times 10, and that this last 10 is an exponent. Some calculators will give you 9.1 with a 10 kind of up and above. Again, you have to recognize that this all means this. Your answer should look like that. So let's do the same thing with part B. Let's write it in scientific notation first. So we'd write 3.78 times 10, and it's 3 spots over, so it'd be negative 3. And we'll put that in parentheses, divided by. And here we want 5.4 times 10. This is 3, 6, 7, 8 spots, positive 8. So we'll type that into our calculators. You should get 7 times 10 to the negative 12.